All right, guys, welcome to our video lesson on Target 1D, our absolute value equations. All right, well, let's dig right in. Before we can talk about what absolute value equations are, we need to make sure we understand what absolute value is. You may have heard about this concept in middle school, but we want to make sure we review it, make sure we're all on the same page. So absolute value, pretty simply, is the distance a number is from zero, right? Okay, it's a distance. So if we look here, the absolute value of -7 is +7 because -7 is 7 units away from 0. The absolute value of +3 is +3 because 3 is 3 units away from 0. Whenever we think about absolute value, we always have to think about distance from 0 on a number line. All right. Now, the fact that we are dealing with a distance tells us something about our absolute value when we're using it to simplify an expression. And that is that distance is never negative. Since absolute value is a distance and distance is never negative, when we use absolute value to simplify in an expression, whatever we simplify to will never simplify to a negative value. It will always be 0 or it'll be positive. All right, so let's take a look at this example right here. So we have the absolute value of 6 minus 15 plus 2. Now, one thing we have to realize here is that absolute values are grouping symbols. This is another reason why PEMDAS will fail you miserably. There is no letter for grouping symbols for absolute value bars in PEMDAS. But what we mean with grouping symbols is that we have to simplify everything inside the grouping symbols first before we apply the absolute value. So we have to subtract 6 minus 15. -9 plus 2 is -7. Now at this point, I have simplified inside the absolute value bars, so now I can simplify the expression. But to do that, we have to know what this expression is saying to us. What this expression is asking is how far from 0 is -7? Well, we saw above that what we're really asking for is the distance from 0, and that distance is always positive, so the answer is 7. All right, so that's absolute value when we're working with it in an expression, right? But what about when we start dealing with an equation? Well, let's take a look at some more expressions here to help us understand how it's going to really fit into an equation. Again, we see 4 expressions here with absolute value bars. And again, the important thing, and we're going to deal with this equations as well, is to know what is it saying to us. What is this expression with an absolute value bar saying to us? So you can see it's how far from 0 is 6, how far from 0 is -6, how far from 0 is 44, how far from 0 is -44. Well, we can see the absolute value of 6 is 6, the absolute of -6 is 6, 44 and 44. All right, what do we notice? Well, that we can notice that 2 different numbers, specifically additive inverses, can have the same absolute value. Well, the reason for that is because we can go 2 different directions on our number line, right? We can go to the left and we can go to the right. So it's possible to have 2 different numbers that have the same distance away from 0. All right. And that's exactly what you see written right there. We can have 2 numbers that are the same distance away from 0, so they'll have the same absolute value. So this means when we are solving an equation and we end up with a variable inside our absolute value bars, there is always going to be 2 values which can make the equation true. Let's look at an example of this. So if we have the absolute value of x equal to 7, again, what we really have to get at is what is this equation saying to us? What it's saying is x is 7 units away from 0. All right, so we have to think about what numbers could x be so that they are 7 units away from 0. Well, if we think about it in a number line, if I'm at 0, I can move 7 units to the right and be at +7. I can move 7 units to the left and be at -7. So my solutions for this equation are +7 and -7, right? All right, well, let's look at it when our equation gets a little bit more complex here. So now we don't just have an x inside the absolute bars, we have an x plus a constant inside our absolute value bars. But we're going to approach this the same way. This equation is saying x plus 1 is 5 units away from 0. Well, that means we could go 5 units to the right or 5 units to the left because there's 2 different ways for this equation, for this statement to be true. And what that's telling us then, because there's 2 different ways that this can be true, we're going to have 2 different solutions, which means we need to have 2 different equations to find those solutions. So let's look here. We can see that x plus 1 can go to the right 5 units and be at positive 5, or x plus 1 can go to the left 5 units and be at negative 5. So one of our equations is going to be x plus 1 is equal to positive 5. The other equation is going to be x plus 1 is equal to negative 5. Guys, the key to understanding where these two equations with the red numbers down there come from is knowing what the equation is saying to you. All right, and we're going to repeat this over and over again in class. So then once I have my two equations, I can just subtract one from each side and I get my two solutions that will make the equation true. All right, so why don't you go ahead, pause the video and try these two equations, and then we'll come back and talk about them. Ready, pause. All right, so let's take a look here. So number one is saying x minus 3 is 14 units from 0. All right, hopefully we thought about that. What is it saying to us? So that means x minus 3 can go to the right to positive 14, or it can go to the left to negative 14. And then I solve the equations and get my solutions. Same deal down below. 2x minus 7 is 9 units from 0. All right, so again, 2x minus 7 can be equal to positive 9, or 2x minus 7 can be equal to negative 9. Then I solve both of those two-step equations and get my solutions. But again, we'll repeat this, what we said before. How do we know that those are actually the solutions of the equation? Well, we can plug them back in. So you can see on the right here, I did the work to plug back in 17 and negative 11 and 8 and negative 1 and simplified. When I did that, you can see that I ended up with equations that are true, telling me that 17 and negative 11 in number 1 and 8 and negative 1 in number 2 are the correct solutions for those equations. All right, well, what happens though when things change a little bit? What's the difference that we see in the equation below here compared to the ones we've already solved? Hopefully you noticed it's that the absolute value bars are not alone. There's a 3 being multiplied by the absolute value bars. All right, and one thing we have to be able to do is get the absolute value bars alone if they're not alone. One other important fact we have to know is we never distribute with absolute value bars. So you cannot just distribute the 3 to the 5x and the 8. What we actually need to do is cancel out that 3, just the same way we do previously when we wanted to get rid of anything that was being multiplied, get rid of a factor. So I want to get rid of a factor of 3, so I divide by 3. If I do it in the left, I do it in the right, and now I have 5x plus 8 is equal to 7. Now I can solve this absolute value equation just as we did before. All right, apply our two equations and solve. What happens though if our absolute value bars are equal to a negative? Now remember what we said, absolute value is always positive. So again, what is this saying here? That our absolute value of 5x minus 25 is negative 10 units away from 0. Well, let's think about that. Can we be a negative distance away from anything? Well, absolute value is a distance, and we said distance is always positive, so no, it can't be. This equation is a false equation. And if it's a false equation, well, then what is going to make a false equation true? And the answer is nothing. There would never be a number in all of existence that will make an equation true. When the absolute value bars are by themselves equal to a negative number, the solution is no solution. All right, so we've kind of covered everything we need to cover here in the video. So why don't you go ahead and try and solve these 4 equations now completely on your own, and then we'll come back and take a look at the answers. Ready, pause. All right, let's take a look here. Hopefully you got these solutions. If you didn't get these solutions, please come to class and ask. All right, we want you to come back and ask questions. You could be right. Maybe we're making one of these an incorrect answer just to test to see if you'll come back and ask us in class why your answer is different than the ones we got here. So please, guys, come back and ask those questions. And we have reached the end. So we will see you in class.